Have you ever stood beneath a towering skyscraper and wondered what truly keeps it steady? Most of us see the obvious: concrete, steel, and incredible height. But engineers see something deeper. They see balance, restraint, and the quiet power of proportions. Today, we're exploring the effective height of concrete columns. It might sound like a technical term, but the lesson it holds is a powerful metaphor for stability, both in structures and in our own lives. When you see a column rising from the ground, it's easy to think that its physical height is what matters most. But engineers know a column actually behaves according to its effective height. That's the height it feels based on the support it gets at the top and bottom. A column could be 6 meters tall, but if its ends aren't properly secured, it behaves like something much taller, more slender, and far more vulnerable. In that simple truth lies one of the most profound lessons in engineering. Imagine two columns, identical in every way, same concrete, same steel. They can perform completely differently, not because of their internal strength, but because of their external support. If a column is firmly fixed at both ends, it becomes stable and confident under load. But if it's pinned or free to move, its effective height grows, and its strength can collapse under pressures it should have easily withstood. This is why experienced engineers learn early on that failure often comes not from a weakness in the material itself, but from a weakness in the support system. There's a story about a young structural engineer working on a high-rise in Dubai. Fresh out of university, he designed a slender, elegant column. The calculations looked perfect, but during a review, a senior engineer simply asked, "Have you considered the effective height?" That one question stopped him cold. He had assumed the beam above would provide full support, but it was actually quite flexible, offering almost no rotational restraint. When he recalculated, he was horrified to find the column was dangerously close to buckling. The mistake wasn't in the grade of concrete or the amount of steel. It was in assuming the supports were stronger than they truly were. This isn't just a lesson learned in Dubai. Engineers all over the world share similar stories. An engineer from Kenya once said that columns fail the same way people do, not because they are inch strong, but because they're expected to carry loads without the right kind of support. Another, from the Philippines, described how a column fixed at both ends might feel restricted, even trapped, yet that very restraint is its greatest protection. In contrast, a column allowed to sway freely looks independent, but it's the first to collapse when the load gets heavy. A consultant in Canada even compared effective height to personal discipline, saying, "Without boundaries, even the strongest person becomes unstable." The more you think about it, the more this metaphor rings true. Life often behaves just like a column. A big dream without a solid plan can collapse under the first sign of pressure. A daily routine without discipline can stretch until it snaps. And a person with no real support system might stand tall for a while, but only until the first real test arrives. Engineers learn through calculations, analysis, and sometimes painful experience that true stability has little to do with outward appearances and everything to do with restraint, alignment, and support. The math is simple. The more restrained the ends, the shorter the column behaves, making it stronger. The freer the ends, the taller and weaker it becomes. In life, the restraints we have, the mentors who challenge us, the rules that guide us, the habits that ground us, might feel limiting, but they actually shorten our effective height, making us far more stable under stress. On the other hand, things that feel like freedom, a total lack of structure, no clear direction, zero accountability, lengthen our effective height, making us more likely to buckle when life gets tough. So the next time you see a building under construction or stand beneath a finished skyscraper, remember what's really holding it up. It isn't just concrete and steel. It's the elegant balance of restraint. It's the honesty of its connections. It's the support it receives from both above and below, just like us. Because in engineering, as in life, true strength isn't about standing alone. It's about being held in the right places, in the right way, so you can carry the weight you were meant to bear. Thanks for watching. If this idea resonated with you, be sure to subscribe for more content that connects our world in unexpected ways.